This video is going to wrap up the rest of chapter 2 for biology. And the topics for this video are going to be solutions, acids, bases, and buffers. And it's in relation to the last video that I uploaded about water. I know I got this weird thing in my eye. I think I hit myself and it bled and it's whatever. Anyway, I'm fine. Okay, so solutions are a mixture in which one or more substances are uniformly distributed in another substance. Basically, that's a homogeneous mixture where the composition is the same throughout. And solutions can be made of solids, liquids, or gases. There's two parts to a solution, the solute and solvent. The solute is the substance that's dissolved in the solution. The particles of the solute can be ions, atoms, or molecules. And the solute then is dissolved in the solvent. It's usually liquid, and in biology, it's almost always water. Now, we measure the concentration of solutions by measuring the amount of solute dissolved in a fixed amount of solution. So the more solute that is present, the more concentrated it is. So an example here, I know it's really pixelated, but you have on a range from, on the left-hand side, you have a very diluted situation, a very diluted solution, all the way up to a very concentrated solution, to give you an idea of what concentration is. Now, there comes a point where the solution cannot hold, the solution or the solvent cannot hold any more solute in it. That is called a saturated solution. The word saturated basically means full. So that's where, for that given volume of solvent, you cannot dissolve any more solute in it. So if you added more solute, it would just sink to the bottom and it wouldn't dissolve at all. Now, for biology, like I said, almost all of the solutions, or all of the solutions we talk about, are aqueous. That means that they are solutions where water is the solvent. Excuse me. Now, one of the most important aspects of a living system is the degree of its acidity or alkalinity. A lot of, when you look at people's health, especially like in an emergency kind of situation where somebody's in an accident, they can learn a lot about the state of your health by looking at the pH of your blood. So what do we mean when we say acid and alkaline? Well, it comes from the ability of water to react with itself. So basically what we have, if I have, so I don't know what's wrong with my voice today. If we have one water molecule plus another water molecule, and this does not happen in pure water, it's only like one drop out of every 10,000 liters that actually does this. But sometimes you can have one water donate a hydrogen to the other water. So that ends up forming two new compounds, or not compounds, two new ions. So if one water gives a hydrogen to another water, that should be the other way around, then you end up with these two new ions. This is something called dissociation, which is the breaking apart of water into two ions of opposite charge. And in the next couple slides, I'll describe what these what these are and how they're related to acids and bases. Okay, so one water molecule dissociates to form two ions. You have the hydrogen ion and the hydroxide ion. So here we're looking at just one water molecule and how it separates into two different ions. You have hydrogen and hydroxide, which is OH. Now, this hydrogen ion is the same thing as a proton, because if you remember, hydrogen is element number 1. Let's review some chemistry, right? And that means that it has one proton. And as an atom, it means it must have one electron as well, because overall the hydrogen atom doesn't have a charge. But when it becomes an ion, it has this +1. That means that the electron was given away. So the hydrogen ion is essentially, or is exactly, one proton. And protons are very unstable by themselves, so it's immediately going to react with another water molecule, which is when you get hydronium, which I talk about next. So the main point here is that when water breaks up into hydroxide and hydrogen, hydroxide is always a very strong base, and hydrogen is a strong acid. So the other ion that's formed is H3O plus, which is called hydronium. Now, the way that we look at acidity and alkalinity, if hydronium is greater than hydroxide, this is an acid. If hydronium is equal to hydroxide, that is neutral. So an acid is a pH less than 7. Neutral is a pH of around 7. And if hydronium, I hope that's, let me move that because it might end up being behind my video. If hydronium is less than hydroxide, that's a base. And so that's how we determine whether something's acid or alkaline or basic. So what are the characteristics of acids? If the number of hydronium is greater than the number of hydroxide, then the solution is an acid. So another example is if we take hydrogen chloride gas and we dissolve it in water. So what happens is the hydrogen and the chloride split up. So you see this hydrogen ion that's immediately going to react with water to form hydronium. And this is what makes it an acid. Acids are considered corrosive, and that's what you see happening in the video down there. The acid is corroding the pear. Now, corrosive basically just means that it eats through the material, whatever it is, and that could be your skin as well. It'd be the same thing. This is a picture of a man who has dropped acid on his foot, and what you see here are the tendons. Those, like, if you see those things moving in my hand, these things here, those are tendons. So that's what connects the muscles to your bone to allow your toes to move. So that has eaten his skin away down to the tendon. Bases. If the number of hydroxide is greater than hydronium, then the solution is called alkaline. So an example is sodium hydroxide. When you dissolve it in water, it forms these hydroxide ions, and then that's what makes it a base. Bases feel slippery because they react with the oils in the skin to form soap. So this person has spilled an alkaline or a basic solution on their skin. And the reason why it works, the reason why soaps work is because one of the ingredients of soap is something called lye, Lye. And lye is a very caustic substance. Now, caustic and corrosive basically mean the same thing, but they indicate the difference between an acid and a base. So acids are corrosive, bases are caustic. So like I said, the reason why soap works is because it uses the base called lye, although it's not very concentrated, it's very dilute lye, but it's reacting with the oils in your skin, and it turns the top layers of your skin into soap, and then that washes away, which leaves fresh, clean layers of skin underneath. And you don't have to worry because your skin's constantly being replaced. So you literally can't wash your hands away. But if the concentration of the base is very strong, then it will turn several layers of skin into soap, and then that's what you see happening here is it reacts with the oils and it turns too much of your skin into soap, and then it just washes away. Painful. So how we measure the acidity or alkalinity, because it's not like black and white, it's not one or the other, it's on a scale. So we use the pH scale to measure how acid or how alkaline something is. And so you just go through a few of these examples. So neutral is 7. At the top end, these are the alkaline substances. You can see human blood is around 7.5. That's why I said the pH of the blood is a good indicator of whether your body is reacting normally to a situation or not. Average seawater is pretty alkaline, about 8.3, I would say. I don't know what that says because it's cut off. This substance, milk of magnesia, that would basically be like your Eno or your Antasil kind of thing. It's like a liquid that you drink when your stomach's upset because your stomach has a pH down here too. So when you have a stomach ache, that basically means that your stomach is overproducing acid. So in order to neutralize that extra acid, you drink milk of magnesia, and that helps to neutralize because if you have an acid plus a base, you get neutral. And then this is the lye that I was talking about. That's all the way up at 13. You do not want to get that on your skin because that will um, be painful. And what do we have here? We've got tomato juice is around 4.5. Apples, lemon juice, battery acid are down here between 1 to 3. So this is the scale that we use to measure the degree of acidity and alkalinity in a substance. Now, buffers are really interesting things because buffers are a mixture of different compounds, but basically, what they do is that they are able to neutralize small amounts of either acids or bases. So, um, these are really good being used to control the pH of organisms because it doesn't matter if something is a little bit too acidic or a little bit too alkaline. A buffer will neutralize both, which is why they're so useful. So, like I said, the pH of organisms is very important in an indication of health. Like your stomach acid and your urine are always quite acidic because in your urine you have something called uric acid, and your intestinal fluid and your blood is alkaline. Your small intestine actually is around a pH of 8, 8.5, because I said small intestine, right? Yeah, because when you eat your food, it's like your digestive system relies heavily on pH because there's a protein in your stomach that is activated by a low pH to turn into an enzyme that starts breaking down protein. But then when the food moves from your stomach to your small intestine, the pH of your stomach acid, it will eat away your small intestine. So that has to be neutralized before or as it enters the small intestine. The food pasty stuff that comes out of your stomach has to be neutralized. Otherwise, the enzymes that are in your small intestine don't work because the enzymes in your small intestine, which are most of the enzymes that are used during digestion, they only work at a pH like slightly more than 8, about 8.5.